Okay, so when we did this bridge in Virginia on a 45-degree skew, we'd never actually tested the HCBs or load tested them on a skew. So we did this in the laboratory at Virginia Tech, and we tested a three-beam assembly with the reinforced concrete deck, and got captured all of the deflection criteria and strains for the skewed bridge. But then once we completed that study, there wasn't enough capacity on the rams to actually load it to failure. So we split it into 3 beams and did independent tests. And the last one we did, Virginia TOT wanted to know, well, what happens if we do get damage to this bridge? So what we did is we took that last specimen, and at center span of the bridge, we actually cut out all of the FRP webs. We cut all the foam out. And then we went in and we cut, I want to say it was 17 of the 27 strands. So we cut well over 50% of the strands. And then we proceeded to load it to failure. And the comparison was the Abacus model. They had already modified the Abacus model to say, okay, what should the capacity be if we had this kind of damage to the bridge? And the Abacus model was wrong. And once we got to the point where we expected it to fail, we pulled out all the sensitive equipment so we wouldn't break anything. And I ran a quick calculation on my HP 15 on my smartphone and said, well, if I got 10 strands at 100% guts and I got this moment arm, what would the failure load be? And I calculated it exactly correctly. And I can't remember what the number is off the top of my head right now. I want to say it was 86,000 pounds of load that we put on a single beam. So now to put that in perspective, here we've got a 2-lane bridge with 8 beams. So for all intents and purposes, you've got 1 truckload or 1 lane load on 4 beams. So each beam needs to be able to take at least 25%, really more with the distribution factors. We took 1 beam out, cut more than half the strands out, and we could support an entire HL93 truck on 1 beam. And that gets back to what I said. I mean, generally, the limiting design criteria on this is live load deflections. And so once we satisfy deflections, we generally have way more capacity than we need for the design limit strengths. And part of that's just because we're using 1860 MPa strand. I mean, if we used a lower grade strand, or, instead of a 1860, used like, 1000 MPa, we'd get much more close to a balanced design between strength and deflections. The other thing I want to point out is that the steel, and we've done studies on this too, the steel is still fully encapsulated in the polyester resin, and it's on the top side of the FRP laminate. So the likelihood that you're actually going to get significant damage to the laminate, and then also get to the strand, and then also get the corrosion to the strand through the galvanized coating, is actually a lot smaller than you got for a pre-stressed concrete beam.